the integral of the square root of x squared minus 2x dx. So this right here is a trigonometric substitution problem, but as you can see, this doesn't fit into any of the forms. But there's a trick. So we know that x squared minus 2x, we can say plus 1 minus 1. So it's the same thing as plus 0. And then we have x minus 1 squared minus 1. And then we can turn this into a u, and that will allow us to get one of these forms. So let's go ahead and do that. We have the integral of x minus 1 to the power of 2 minus 1 dx. Then let u equal to x minus 1. We have the integral of the square root of u squared minus 1 dx. And we have to convert the dx into the du by doing the derivative. So du over dx is equal to 1. So du is equal to dx. In these three forms, we can see that x is the variable and a is the constant. So same thing here, we have u as the variable, u squared minus 1, and 1 is a squared. So we have u equals a secant theta. So obviously it belongs to this form. And this is what we have. And in the square root, we can see that a squared is 1. So a is 1, and u is equal to a times secant, which is 1 times secant, and we can just write it as secant. What is the derivative of secant? The derivative is going to be secant tan. And we need to multiply both sides with d theta to get du. So we have du is equal to all of this times d theta. So I put all of the important pieces of information here, and we will reuse this later on. And this integral is equal to u squared, and u is secant. So we have secant squared minus 1, and du. du is secant tan. Secant tan d theta. We know that tan squared plus 1 is secant squared. So if we subtract both sides with 1, we get tan squared is secant squared minus 1, which is basically this part. So we can replace this with tan squared. This is equal to the integral, and the square root of tan squared is just tan, times secant times tan d theta. So tan times tan gives you tan squared again. What we can do here is convert all the tan into the secant, so it's easier for us. Let me show you. We have the integral of tan squared, and remember tan squared is secant squared minus 1 times secant d theta. So this is equal to secant to the power of 3 minus secant times d theta. The next step is to split the integral apart. So we have secant to the power of 3 d theta minus the integral of secant itself. So I've made separate videos to explain the integral of secant and the integral of secant to the power of 3. You can refer to those ones if you want, but here are the formulas. So continuing on, the integral of secant to the power of 3, that's this part here. And we're just going to multiply 1 over 2 with these terms. So we have 1 over 2 times secant times tan plus 1 over 2 times the ln of the absolute value of secant plus tan. We finished this part. Now we have to minus this part. So minus the antiderivative of secant is the ln of the absolute value of secant plus tan. Now as you can see, both of these are the same. They are the same term. So we can simplify this. We have 1 over 2 of this minus this part, which gives us negative 1 over 2 of ln of secant plus tan. And then don't forget our initial part, which is 1 over 2 times secant times tan. And then plus c. This is where our initial assumptions come in. So u is equal to secant, which is u is equal to 1 over cosine, because 1 over cosine is secant. Then we have u times cosine is equal to 1, and cosine is 1 over u. Using the SOHCAHTOA rule, we can see that cosine is adjacent over hypotenuse. So the adjacent side is 1, and the hypotenuse is the u. We need to find this side. So let's call this side a. According to the Pythagorean theorem, a squared plus 1 squared is equal to u squared. So a squared is u squared minus 1, and a is the square root of u squared minus 1. If we look at our antiderivative, so here's our antiderivative. We already know what secant is because secant is just u. The only thing we need to know is what is tangent. So tangent is equal to opposite over adjacent. So the opposite side is u squared minus 1, and the adjacent side is 1. So divided by 1. And since it's divided by 1, we do not need to write that. So we have 1 over 2 times secant, and secant is just u. So times u, and times tan. And tan is the square root of u squared minus 1. And then minus 1 over 2 times the ln of absolute value of secant, and secant is just u, plus tangent, and tangent is the square root of u squared minus 1 plus c. The last step is to convert the u back into the x because our original integral is in terms of x. So we have 1 over 2 times u. And what is u? Well, u is x minus 1. So times x minus 1 times the square root of u squared, which is x minus 1 to the power of 2, then minus 1. And then we also have to subtract 1 over 2 times ln. Let's write it down here. So minus 1 over 2 times the ln of the absolute value. Now let's go ahead and convert all the u's to the x in here. And plus c. So this right here is our answer.